Hello and welcome. Today we'll be going through the OptiAssist for Simcenter3D tutorials. This is the RDM tutorial 2, load path development for a helicopter body. As you can see, I've already got the model loaded up. The first thing we are going to do is we are going to go over to the FEM file. Underneath the drop down we are going to hide certain 2D collectors. For this we will hide the windows, left hand front, left hand rear, right hand front, front and rear door. Once that is done, we will then hide the polygon geometry as well as the constraints. This makes the model easier just to understand and visualize. And so once you have done that, we will go over to RDM optimization to begin setting up for the model. Here we come to the optimization setup window containing the 6 tabs. For the first tab, the subcases, we will select both load cases and then click next. Under the design rules, we'll click new to create a design rule. From the RDM creation method, we'll change it from existing mesh to block search, and the selection method will remain displayed. We will set the block search distance to 150 and the target mesh size 100. For the creation coordinate system, we'll change it to inferred before selecting the coordinate system at the tip of the model. For the material selection, we want to keep it as select local material, and the material will be aluminium 6061. For the property factor, we'll change it from 1 to 0.1 and then click create mesh. Once the mesh has been created, we'll select finish and then next. Under the manufacturing constraints tab, we will create the first constraint type to be planar symmetry, which we will infer to be at the point of the model going in the global X direction. Once you have done that, we'll click next again and come to the goal tab, where the goal type will be maximize stiffness. We want the mass fraction to be 40%, or in this case 0.4, and then selecting both solutions. Clicking next. No further constraints are required, so again we'll click next. And under the settings tab, we will change the design cycles from 15 to 35. Once you have done that, we'll click OK. And the model is now ready for the optimization. Under the OptiAssist ribbon, we'll click Solve, and the optimization will begin to run. Once that is finished running, we can take a look at the design history. If we close down all the windows and under the OptiAssist ribbon, click Design History and Plot. Here we can see the design objective, in this case the compliance, decreasing as the design cycles continue for the optimization. As this is the inverse of the stiffness, the goal of the optimization, we know that it has in fact worked. If we take a look at the constraint violation, again, in the short space of the design cycles, it dropped to 0. Closing that down, we can now take a look at the plot. If we go over to OptiAssist and click on RDM plot, change the density threshold to 0.8, latest cycle, and hit plot, we can then see the RDM that's been generated from the optimization. To create and look at a smoothed STL, we click on Export STL and save. OK. If we then click File, Open, 412, and then File, Import, STL, look for the file. Okay, it has been imported. To view it better, we will just click on the bell here under the paintbrush. We'll then change this to 80%. Here you can see the reinforcement that's been made and then applied to the model based upon the optimization. Once you're happy with that, we can click cancel and close that. And now we can update the model based upon the results. So again, underneath the optimization tab, click on update model from results, load results, latest cycle, and we want it at 80%. We'll click OK. Yes. And the RDM has now been applied to the model. This concludes this tutorial.